V33 covers multi-step equations and begins on slide 141, ending with slide 161. Multi-step equations may look scary, but really they're made up of many one-step equations. So as the equations become more complex, just remember the first thing you need to do is simplify each side of the equation, which requires combining like terms in the distributive property, and then you're going to use inverse operations to isolate the variable and solve the equation. Just a reminder, whatever you do on one side of the equation, you have to do on the other side. Slide 143 demonstrates how to solve this multi-step equation. So the first rule is to simplify each side. Well, here on the left side, we need to simplify. The right side only has one term, so there's no simplifying there. There's nothing to distribute, so the first thing we do is combine like terms, which are the x terms. So 5 plus 7 simplifies to 12x, and I bring down the rest of the problem. 12x plus 4 equals 28. So now I want to make the x stand alone. In order to do that, I'm not going to work with the variable term. Instead, I'm going to work with a constant. And in order to undo addition, I have to subtract. I'm going to take away 4 on both sides and then bring down my 12x. So 12x equals 24. Now I have 12 times x, and the only way to get rid of the 12 is to do the inverse operation, which is dividing by 12. So I divide by 12 on both sides, and x ends up equaling 2. I have to see if my answer is correct by checking into the original problem. So 5 now not times x, 5 times 2 plus 7 not times x times 2 plus 4, and in the end I have to simplify my steps and see if 28 is the end result. 5 times 2 is 10, 7 times 2 is 14, 10 plus 14 does in fact equal 28, and so in the end my answer, x equals 2, is correct. I'm going to demonstrate two multi-step equations on slide 144. So first take a minute and please rewrite 12h minus 10h plus 7 equals 25 to the right of the three examples. So first I have to check, is there anything to distribute? No, there isn't, so the first thing that I need to do then is to combine like terms. In this case, I have two h's and one constant, so I have to combine my h terms. So 12h plus negative 10h equals 2h, and then I bring down my constant in the rest of the problem. I don't want to work with my variable term just yet. I want to work with the constant, so I have plus 7, which means I need to subtract 7 on both sides. So 7's cancel out on the left, my 2h gets brought down, equal sign gets brought down, and 25 minus 7 is 18. I have 2 times h, so I need to undo the multiplication. In order to undo multiplication, you're going to do the inverse, which is division by 2 on both sides. The 2's cancel out, and you're left with h equals 9. I think that's correct, so I have to check, and I'm going to go back to the very first equation that's written, and everywhere I see an h, I'm going to plug in with the 9. So 12 times 9 plus negative 10 times 9 plus 7. 12 times 9 is 108. Negative 10 times 9 is negative 90 plus 7. 108 minus 90 is 18 plus 7 is in fact 25. So therefore, I end up with what I needed to end up with, h equals 9. Still on slide 144, I'm going to demonstrate the second equation. So on the lines to the right of slide 144, please recopy the equation. Negative 17q plus 7q minus 13 equals 27. There's nothing to distribute here, so the first step is to combine my like terms. I have two q terms and one constant, so negative 17q plus 7q, they are negative and positive, so I need to subtract the 2. 17 minus 7 is 10. Negative 10q minus 13 equals 27. I'm not working with my variable term, I'm working with the constant, and because I have minus 13, I now need to add 13 on both sides. So minus 13 plus 13 cancels out, and I have 27 plus 13 on the right side of the equation. I didn't use negative 10q, so that gets brought down, equals 27 plus 13 is 40. In order to undo negative 10 times q, I have to divide by negative 10 on both sides. Negative divided by negative is a positive, and the 10s cancel out, so I'm just left with q on the left. Positive divided by a negative is negative, so h equals negative 4. In order to check and see if that's correct, the negative 4 has to revisit where the q's were. So I have two places that I'm multiplying by negative 4. Negative 17 times negative 4, 7 times negative 4. So my second line simplifies. Negative times a negative is positive, and it becomes 68, plus positive times a negative is a negative 28, minus 13. 68 minus 28 is 40, minus 13 is 27. So in the end, my equation is balanced, and in order to balance it, h has to equal negative 4. We're going to save the third example for class tomorrow, so please turn to slide 145. Slide 145 just gives a quick review of the distributive property. Before you can combine any like terms, you need to distribute. So just a reminder, when you have the distributive property, you have to do the outside times the first term, which is 5 times 20, plus the outside times the second term, which is 5 times 6. Again, outside times the first, 9 times 30, minus, or you can keep change flip, outside times the second is 9 times 2, and so on. Slide 146 gives an example of a multi-step equation where before I can combine any like terms, I need to distribute. And I can't work in the parentheses because I have two unlike terms. So the only way that I can combine those terms is by getting rid of the parentheses, which is through distribution. So I'm going to do 2 times b, which is 2b, minus 2 times 8, which is 16. And again, you can do keep change flip here. The PMI slides do not do that, but you know I always recommend keep change flip. I'm not working with the variable term, so it's minus 16. In order to get rid of the minus 16, you do the inverse, plus 16 on both sides. So 16s cancel on the left, and all that you have is 2b, and 28 plus 16 is 44. And now we have a nice and simple one step left, where in order to isolate the b, you divide by 2 on both sides. So in the end, b equals 22. PMI didn't do the check, so if you look over here, the b is 22, so in the original problem, instead of a b, I'm going to rewrite with a 22. Now, in the parentheses here, I can simplify that because they are like terms. So 22 minus 8 is 16, and then I do 16 times 2, which is 28, so therefore b equals 22 balances the equation. Before I leave you to solve problems independently, I want to show you an example of a multi-step equation involving the distributive property. So on slide 147, please take the first equation and copy it to the right of the examples. 3 times w, I did a keep change flip, plus negative 2 equals 9. Well, in PEMDAS, the first step is to work in parentheses. I cannot combine w and negative 2 because they are unlike terms. So I have to remove the parentheses through the distributive property. 3 times w and 3 times negative 2. So my second line is going to read 3w plus negative 6 equals 9. And now I have a two-step equation. 3w plus negative 6 equals 9. In order to undo and get w alone, I'm not working with the 3w, I'm working with the negative 6. The only way to cancel out a negative 6 is through its additive inverse, which is positive 6. So I add plus 6 on both sides. The 6's cancel out, and I'm left with 3w equals 15. Lastly, I have a one step, divide by 3 on both sides, and w is equal to 5. I want to check and make sure that's correct. So I go back to the very beginning, and where my w is, the 5 is going to take its place. So 3 times 5 plus negative 2. And I can work in the parentheses because they are like terms. So 5 plus negative 2 is 3, and 3 times 3 is 9. Therefore, w equals 5 is the correct answer. Please skip the second and third example unless you want to try it on your own, and we'll go over these in class together. Slide 148, you are going to now work independently, so pause the video and work on 148, 149, and 150. When you finish 150, please draw a snowman on this slide. Once your snowman is done, you're going to skip through 151, 152, 153, and then you're going to start again on slides 154. Pause the video and work out distributing. So you're going to distribute 154, 155, and 156. You are at the end of this podcast. Any slides that we skipped, we're going to work out together in class tomorrow. Please make sure that you are checking your work for all of your equations.